Hello everyone and welcome back to ImTechnos. Today we are diving into Amazon Elastic File System or EFS. Stick around as we explain what EFS is and walk you through a hands-on demo to set it up and use it. Let's get started. Imagine you are running a web application on multiple EC2 instances and they all need to access the same set of files like user uploads or shared templates. That's where Amazon EFS comes in. It provides a shared file system that you can mount to all your EC2 instances. This setup ensures consistent access to data across instances and simplifies scaling the application as traffic grows. So, what is Amazon EFS? It's a fully elastic file storage. At its core, file storage organizes data in a hierarchical structure. You start with raw data, which is saved as individual files. These files are placed into directories like folders on your computer. And those directories live inside what we call volumes. Now, these volumes can be mounted by multiple clients like EC2 instances or on-prem servers at the same time. However, each client must have the right permissions to mount the file system and browse through the directories securely. Amazon EFS allows multiple systems to share and access the same data reliably and consistently. Now, coming to the features of Amazon EFS, it's a fully serverless file storage service, which means AWS takes care of provisioning, patching, and infrastructure management. So you don't have to worry about any of that. First, EFS supports the standard NFS protocol. This is the network file system, which makes it instantly compatible with most Linux environments without any extra setup. Next, it's elastic and scalable, meaning it automatically grows and shrink as you add or delete files. There is no need to plan ahead or manually adjust storage size. EFS handles it for you. It also supports shared access, so multiple EC2 instances or even on-prem systems can connect to the same file system at the same time. This makes it ideal for distributed workloads. Amazon EFS is designed to be highly available and durable. It stores your data redundantly, providing built-in resilience and minimizing the risk of data loss. You can also get performance options to choose from, whether you need low latency with general purpose mode or high throughput with max IO mode. EFS lets you tailor performance to your workloads. On top of that, it helps with cost optimization. You can set lifecycle policies to automatically move infrequently accessed files to a lower cost storage class, saving money over time. And security is built in as well. EFS supports encryption both at rest and in transit and integrates with IAM and security groups to control who can access your data. Finally, Amazon EFS works seamlessly with other AWS services like EC2, Lambda, EKS, and AWS Backup, making it easy to integrate into your existing architecture. Now let's understand how Amazon EFS works. At the bottom of the architecture, we have Amazon EFS, which is the central shared storage. It is fully managed, automatically scalable, and accessible from multiple instances concurrently. There is a security group with NFS protocol attached to EFS, allowing EC2 instances to mount the file system. And then we have two EC2 instances, one in each availability zone. These are your compute resources that will access shared files from the EFS through a mount target. Each subnet has a mount target, which is basically a network interface that allows your EC2 instances to connect to the EFS file system. These mount targets are required in each availability zone where your EC2 instance is running. Please remember that the mount targets are created per availability zone, not for each instance. Let's say I have 10 EC2 instances in one availability zone. I only need to create one mount target and all the instances can connect to the EFS through that single mount target. Coming to the implementation, first we'll create a security group with NFS protocol open. Next, we will create Amazon EFS, associate with the security group we create, and enable the mount targets in all availability zones for high availability. Then we will launch two EC2 instances, one in each availability zone. After launching, we will connect to these EC2 instances from our local device and configure them as NFS clients. Because to access a file system server like EFS, you need a file system client. So the EC2 instances will act as those clients. Finally, we will mount the elastic file system to both the EC2 instances and create files at one instance to verify that the same files are accessible from the other, demonstrating real-time shared access to the same file system. All right, now that you have understood the setup and flow, let's switch over to the AWS console and get started with the hands-on implementation. I am in the AWS Management Console working in North Virginia region. Let's start by creating a security group. So go to EC2 dashboard using the search bar. In the left navigation pane, click on dashboard, then select security groups. Click on create security group. Give it a name, let's say EFS security group. And for the description, enter EFS-NFS, indicating that NFS protocol will be used by EFS. Under the inbound rule, click on add rule, search for NFS and select it. For the source, choose anywhere IPv4. Finally, click on create security group. Okay. Now our security group is ready. In another tab, search for EFS in the search bar and select it from the results. Click on create file system to go to the easy create page. However, we will click on customize to explore more options. You can optionally provide a name for your elastic file system to easily identify it later. For example, I will name it as EFS demo. This is just for our reference. Under file system type, you will see two options here. Regional, which is selected by default. This stores your data redundantly across multiple availability zones within the region, ensuring high availability and fault tolerance. This is ideal for production grade applications. And you have one zone. This is cheaper option, but stores data in just one availability zone. So this is suitable only for test or dev workloads where durability is less critical. For now, I'll go with the default option, which is regional. You can enable automatic backups by simply checking this box. When this is enabled, AWS Backup will automatically back up your EFS file system based on recommended best practices. I suggest keeping this disabled for now as it costs additional charges. In Amazon EFS, data can be stored in different storage classes based on how frequently it's accessed. So standard storage class is designed for files that are accessed regularly. It offers low latency and high throughput, making it ideal for active workloads, but it also comes at higher cost. By default, the data is stored in the standard storage class. For files that are not needed as often, infrequent access storage class provides a more cost-effective option. It's suitable for data that's accessed less frequently, but still needs to be available quickly when required. So to help manage cost efficiently, Amazon EFS offers an automated feature that transitions your files between these storage classes based on usage. You can start by setting how many days after the last access a file should be moved to infrequent access. For instance, if you select 30 days, any file not accessed in that time will automatically shift to infrequent access storage class, reducing cost. Then there is archive storage class, which is most cost-effective tier. It's best for long-term data that is rarely accessed. To save even more, you can configure data to transition into archive storage after long periods of inactivity. While this tier is more economical, it does come with increased latency when retrieving data. If a file is stored in infrequent access or archive storage class is retrieved again, EFS can automatically move it back to the standard storage class for better performance when you select this option. Alternatively, if you prefer more control, you can disable this automatic transition. So for this demo, I'm selecting none for all the three options. Next, we have encryption. Enable encryption of data at rest is enabled by default and ensures your file system data is encrypted using Amazon KMS managed keys. You can also click on Customize Encryption Settings if you want to use your own KMS key. However, I'm disabling this option to avoid cost. Under Performance Settings, we have Throughput Mode. This controls how data transfer speed is managed. Enhance provides higher throughput and more flexibility than bursting, especially useful if your workload is variable. Within Enhanced, there are two options. Elastic, which is recommended, this auto scales based on how much data you are using and works great for most workloads. And Choose Provision if you want manually set the throughput, usually for workloads with steady, predictable data transfer. Bursting mode scales with the amount of data stored. Let's select this since we only need basic performance. For performance mode, you can choose general purpose, which is ideal for wide variety of workloads, including those that are latency sensitive. Alternatively, if you have highly parallel workloads such as big data or media processing, max IO is the better choice. So let's go with the default option, which is general purpose. Finally, you can add tags to organize your resources better. For example, you can enter key as environment and value as testing. Once all this is done, click Next at the bottom right to continue to the network configuration step. Now, under Network, this drop-down lets you choose the VPC in which your Elastic File System will be available. Only EC2 instances within this VPC can mount the EFS. Select the only option available. Mount targets are the entry points that allow your EC2 instances to access the EFS. Think of them as network gateways within different availability zones. AWS recommends creating one mount target per availability zone to ensure your EC2 instances, regardless of the zone, can access the file system with low latency and high availability. This is the availability zone where your mount target will be placed. By default, mount targets are enabled for almost all availability zones. You can remove any unnecessary ones and add them later at any time. For example, let's add a mount target for 1E availability zone. Each availability zone requires a subnet within the VPC. This dropdown displays only the subnets that belong to the VPC you selected earlier. Here, you can assign a specific IP address to the mount target or leave it set to automatic. Most users leave it on automatic unless there is a specific need to reserve an IP address, for example, for whitelisting or static routing. Now, the last part is crucial. Security groups control which traffic is allowed to connect to your mount target. Currently, the default security group is selected. Let's update it by removing the default security group and applying the custom security group we created earlier for all mount targets. So if you see the architecture, selecting a custom security group with NFS protocol in the inbound rules allows the EC2 instances to mount to EFS. So click Next to proceed to the File System Policy section. This step is optional, as you can control EFS access using other AWS mechanisms like security groups, mount targets and subnet permissions, IAM roles or policies attached to the EC2 instances. If you want more control, AWS provides quick checkboxes to apply common security best practices without writing any code. This includes preventing root access by default, blocking all write-delete operations by default, blocking unauthorized access, requiring all EC2 instances mounting this EFS to use encryption in transit. If you want to define custom IAM permissions, you can use the policy editor to manually write a custom policy. For now, I'll keep this step optional and click Next. Review and create is essentially a summary of all the settings you have selected so far. Scroll through and double check each section. If something is off, click previous to go back and fix it. If all looks good, click create. As you can see, the file system is being created and is in available state. In part 2, let's launch two EC2 instances in two different availability zones and connect to them using our local machine and verify that the files are shared. That's it for this part. If you have any questions, feel free to drop them in the comments below. Thank you for watching and stay tuned for part 2. Take care and happy learning.